Hello, everyone. Do I need to? Is this okay? Can everyone hear me? All right. Welcome to my talk. I've been developing software for over 14 years now. I started all the way back with the .NET Compact framework, building software for industrial PDAs. Up until now, where I use .NET Core mostly to create backend APIs and Angular frontends and Xamarin frontends in mobile applications as well. And I've been a consultant for over 7 years, and I decided after 7 years of consultancy that I had enough, and I joined my current company, UCB, which is a biopharma company in Belgium, as an internal lead developer. So I have my own team now of 4 people. Of course, yeah, my name is Wesley Cabus. As you can see, my Twitter handle is @WesleyCabus, one word. But of course, you didn't come here to learn more about me. You wanted to learn more about chaos engineering and how to do it inside your applications and services. And let's see what the plan is for the next hour. So we're going to start with a little introductions on chaos engineering, because can I get a quick show of hands who has done nothing with chaos engineering yet? That's what I thought. So when I did this talk the first time in Tech Days Finland, I had a similar result. So I thought it was a good thing to give a first introduction on what is chaos engineering, so that at least everyone has the basics set, right? And then I'll introduce some example of companies that are actively using chaos engineering. And after that, I'm gonna scale it down, because most of the companies that are using it right now are very, very big companies. And what they do does not apply to everyone in this room. Of course, I will not only be talking about the topic with the slides, I will also show you some examples, introducing Row, the open source library that I'm creating, so that to show you how you can do chaos engineering inside your .NET code bases. So we all know Netflix, right? Netflix is one of the biggest companies in the world with movie and TV shows subscriptions. I think most of us in here probably has a subscription as well. But apart from their marketing strategy and their huge catalog of movies and TV shows, what makes Netflix so popular? Well, I have no clue, because I'm not in marketing. But I do know that if I use their apps, or if I go to their website and start streaming something, it almost always works. I almost never have an issue with the application, but if I do, I can just, close it, start it again, and it works. It just works. And the reason why that their services and their applications are working so well is because they are using chaos engineering. They are applying chaos engineering to their apps and services all the time, even in production. So they have created Chaos Monkey, which is a set of services that you can use, agents that you can deploy. For example, let's say they have a microservice architecture, right? So they have a login service, and Chaos Monkey will just say, I'm now going to unplug the login service for Australia, which means that all of you can't log in anymore in a normal situation. But what happens is that because of their infrastructure, they will just reroute your requests to another service. So they will reroute you to, let's say, Japan or Hong Kong, and you will be able to log on again without you even realizing that it happened, because it's so fast. That's just one of the chaos monkeys that they have. So they could, for example, deploy an agent to the same box that runs login service and let it spike the CPU for 80%, so that the CPU doesn't get the time to do something else, which it should do. It should handle login requests. Or they could introduce an agent that creates lag on the network interface, so that all of your requests are taking way more time to be handled. And by introducing all of these chaotic events, like the CPUs spiking and the network lag, they can start to see how much impact that a certain load or lag spike could have on their infrastructure and try to mitigate those events from happening before they actually happen, because they are causing it themselves. They're actually causing sort of denial of service attacks, but managed. So they can be the hackers, they can beat the hackers to it. They can make their infrastructure more robust, their software more robust to deal with those events before they manifest themselves. And of course, this helps Netflix to check if all of their services are being programmed correctly and used correctly, and if their infrastructure contains enough nodes to deal with all of these load spikes. Another large example is Amazon and Audible, you know, the audiobooks. And they also use chaos engineering to stress test all of their services. And they use Gremlin, also something that they created themselves, to, again, add CPU load or lag spikes. But what they also have is the ability to inject code into their Java systems. So now they can go further and say, we're going to create a service that's going to misbehave on a different level. It's going to throw exceptions all of a sudden. And this could be interesting because if you can introduce exceptions in your code, you can start simulating stuff that you couldn't simulate before. Like, well, you could still try and simulate running out of memory or disk space, but it's a lot easier if you just throw an I/O exception saying, hey, my disk is broken. It's going to be easier than actually going to your server and putting the hammer on a disk to break it. Now, chaos engineering, in effect, it's more about performing experiments on a system rather than running tests. So when you create a test, you define an assumption, and the test will verify whether that assumption is true or false. Or simply put, you know how a system is supposed to behave when you give it a specific set of data and you let the data flow to your system, like a unit test. You set up your service, you say, when I give you this parameter, I should get that result. And the same applies to chaos engineering. Wait, let me go back. So you have your unit testing, and those help in validating the business logic, but it only applies to what you know. While chaos engineering goes a bit further. You start to experiment outside of the box, outside of the rules. And you could say, what would your system do when it can't reach a service? Because you're building an API which has a Cosmos DB or Hadoop database or a SQL Server, and all of a sudden your SQL Server is not there. So how do you respond to those events? Or what would happen if you deploy your application to the cloud, and a lot of companies, when they start with cloud, they just deploy to one region, but all of a sudden that region goes down. I remember that there was a fire one time in one of the East US data centers, and the entire network went down. The entire data center was gone. So if you only deploy to one region, what happens? You're not aligned anymore. Or what else could happen? This is out of your control, but let's say that you have deployed an application to multiple regions, and as part of the update progress, you're going to bring a region down, upgrade that region, and spin it back up. So while you're bringing it down, all of your traffic goes to another region. But can you bring it back up again? Can you test this if it works? Now, this is all, Netflix, Amazon. I don't work for Amazon, so I can't just deploy stuff like they do. So I'm gonna scale it down now, because while I was reading and watching videos about chaos engineering, I kept thinking the same thing. This is great, chaos engineering, it's awesome, but no way that my company is gonna let me do that on that scale. And if I would propose to add chaos in production, well, let's just say that I'm glad that my manager is not in this room. So what I'm gonna do is scale it down. we're going to start controlling the chaos, which is also part of chaos engineering. It's not just let's throw a service down and see what happens. No, because if you would say that you're working in multiple teams on the same system, so you're responsible for microservice A, other team is responsible for microservice B, but both of you are running on the same SQL server in your dev environment. Could you imagine your team's faces when you start spiking that SQL server? I don't think they will be happy with you as a team. So we're not going to do that. We're going to make it more controllable, you can add it to your own code base. And you could say, instead of my SQL server or my other service being unavailable, I'm just going to pretend that it's unavailable instead. So I can do this now in my code base where I can control the chaos. And I can choose what kind of chaos I want to add, where I want to add it, and when it runs. So it becomes manageable. And you can then see if something starts failing, was it planned or not? Because if it was not planned, it might be another issue. So now you can choose to add chaos, also to add it to certain environments. You can say, we'll add chaos to our dev environment, or an acceptance environment, or just create a chaos environment if you want to. Of course, you can still choose to run it in production if you really want to do so. But I think the most important part here is that you can now start experimenting with this and also help convince other people, not only your dev team or your testing team, but also your stakeholders, to see, hey, we built this thing and we can assure you that if suddenly we get like an increase of 200 or even 1,000% of usage, we can still cope with this because we tested this. Now, you might also start to wonder, do you really need to add all of this chaos engineering stuff? Because, you know, you're building services, you're running them in the cloud, you do host them in multiple regions, so you're good with one region going down. You've tested all of your code, you have unit tests, you have integration tests, you have monitoring. So everything, you're ticking all the boxes, think you're safe. But let me tell you about two situations. The first situation that I encountered was during my first job. We were building software on the PDAs, and they were like these ruggedized devices with barcode scanners, mostly to create track and trace solutions inside big warehouses. So typical order picking solution that we load data on the system, go around in a warehouse, scan the order items, and then collect everything. And when we were discussing one of our solutions with a customer, we also asked them if they needed an online, always-on solution, or if we needed to implement an offline solution as well. Because back then, in the year 2005, warehouses didn't typically have a decent Wi-Fi connection. So yeah, you can see on the picture also lots of metal and concrete, so getting a signal everywhere was not that great. Now, of course, more often than not, they choose the always-on method because it was cheaper. And then we asked them, okay, always on, fine. But just in case, do you want us to do like a wireless survey to measure if you have a decent connection everywhere? And they said, nah, it's fine. Our own IT guys, they have done this already and we should be good. Yeah, I think you can already realize that we found out rather quickly that the warehouse was not that well covered in Wi-Fi at all. But yeah, their feedback was not that helpful. Their feedback was just, your applications are crap. Welcome. I always love a bit chaos in chaos engineering talk. So yeah, their feedback was not very helpful. But fortunately for us, we had logging in the software that said signal down, signal up, signal down, signal up. So we knew what was going on. The second situation is a bit more recent. This is actually my CEO on the picture. He had to go to Rwanda in Africa for a project of ours, and we actually deployed a server in a box. So a suitcase with a server in Rwanda, because the data centers over there, they're not really that online. Imagine a data center having no internet for days. That's actually normal over there because the power is not that stable. So while they are used to this, we had no clue. We were just building this application in our own office. We have Wi-Fi all the time. We're actually getting quite mad if our internet connection goes down for like a minute. But over there, yeah, there's no internet. No worries. Happens all the time. So we had to cope with this, and we realized, of course, when we got the requirements that this application might be down for some time, but there's a big difference between being down for an hour or being down for days or even weeks. So we had to make sure that we could handle this in this application, but how do you test this? Now, both cases illustrate the same problem, dealing with poor connectivity. This is just one of the things that can happen in applications. And poor connectivity can easily be simulated by developers by, if you simulate an application on an Android simulator or an iPhone simulator, you can say, hey, airplane mode. But that's a bit cheating, because if you do that, the airplane mode will disable every connection, both mobile, Wi-Fi, Bluetooth, everything. And it also gives you a system event that you can hook into to say, I'm going down and I'm switching now to my cache or my offline state. But while it simulates dealing with offline situation, it does not simulate actually having no connection at all or having a very bad connection. And this is just one example of a situation that might occur on a device or in a service that's beyond your control. There are, of course, many situations out there that you can't control, ranging from your SQL Server running out of memory, out of disk space, disk breaking down, or a data center becoming unavailable because of a natural disaster, something that you can't control. At least I hope you can't. And of course, while for most applications, it might be okay to be down for a while, it might even be okay to lose a small part of your transaction. But if you're dealing with financial sectors, pharmaceutical ones, if you lose one bit of data, you're done. You're out. You might lose millions of dollars. So you don't want to do that. So I started working with an idea. And this is already quite some time ago, because I've seen the talks on chaos testing and engineering. And I wanted to introduce this back when I was a consultant at the company that I was working for. But of course on a smaller scale, because again, I was at that time working for ArcelorMittal, the great steel industry. And they would not be very happy if I was just, hey, I'm the Mr. Random Consultant. I've deployed this little piece of software that you don't know on that server, and it's gonna, just do nothing until I say that it should spike the CPU to 80%. I don't think I would have stayed at ArcelorMittal for very long if I would try to do this. I couldn't even do it. I didn't have the rights to do so. So I would need a different approach, and I would need to do this in my code base, but there was nothing out there for me to do so. I had to create this all myself. So I started working on my open source library called Rutro. Fans of Scooby-Doo have the link. And in its essence, it's nothing more than a tool to wrap services, just like a mocking framework in unit testing. But the difference here is, instead of just faking a call and not doing anything, I'm going to inject something else that says throw an exception, or if you connect to that service, I'm gonna intercept it and slow it down and then return whatever you wanted to return. But it's gonna be easier just to show you how to do this. So let's add a little bit of chaos to a UWP application instead. Let me get my live coding script. Don't know if there were many live coding sessions already, but here's one. So I have this application and I'll quickly run it for you. It's an application that was built by Microsoft to demonstrate UWP. It's called the Van Aersel inventory. And it showcases, MVVM, model view, view model, Windows Hello, so I can enter my PIN code to log in. And it has let me zoom in a bit, these fancy new Fluent design features. And it also showcases the use of SQLite and SQL Server, so you can switch database if you want. It's a nice small application to play around with. And they also use the Microsoft dependency injection extensions that they created for ASP.NET Core, which makes it very good for me because I actually use these also to inject my effectors and my chaos engineering into the code. So I'll go over to the package explorer and add a package to this project. Oh. I have to tick the include pre-release box because I'm still working on it and it's still in a beta state. Let's hope that the internet is working. Oh yeah, if you look for install, that won't work if you don't install it yet. So I have two packages at this time, and the first one is the core package. It contains all of the logic that's actually going to inject code into your code base. And the second one is tailored specifically to enable you to override services that you have configured with the Microsoft Dependency Injection library. So I'm going to go ahead and add this one to my project. And then in the service locator class, this is where they have configured all of their services. So you can see they have a lot of singleton services, some scoped, and then all of the view models are transient, so they will be renewed every time you create one. And just before the last line, when they built a service provider, it's time for me to add some chaos. There we go. And the first thing that I'm going to do is I'm going to play around with Windows Hello. Because Windows Hello allows you to, use your fingerprint reader, iris scanner if you have a fancy laptop, to log into your applications, to log in Windows. But what would happen if your fingerprint reader service or driver has an issue? Would it give you a blue screen? Would it crash Windows Hello? Would it crash your application? There's no way to tell. So if you just call into Windows Hello, there's no way to simulate what would happen if Windows Hello starts failing. You're just relying on an external service. So I'm going to fake that service from being disruptive. So I know that we have a login service here. I'm going to copy that line because I'm lazy. And instead of adding this service again because it's already been configured, I'm now going to affect this service instead. And for this, I need another namespace. So I'm going to affect this singleton service, and this is in that Microsoft Extensions Dependency Injection package. And just like what you would do with a mocking framework, I'm going to say, okay, when I'm calling a method called sign in with Windows Hello Async, which is a method on the iLogin service, I'm going to throw an exception. And for this, I need the row namespace. So now when you call sign in with Windows Hello Async, it will throw an exception instead. Of course, yeah, like this, if I would now start the application, it will throw an exception every time. And even for me as a chaos engineer in becoming, this is a little bit too much, so I'm going to limit this. And I added some triggers. The throw is what I call an effector because it affects your method. And these are triggers. So you can say only trigger after a moment in time, after it's been called n times, at random, just, make it crash whenever you want. I do not, did notice that before. That's because I'm zooming in. At random is, I just added it, but I would not suggest using it because you want your chaos events to be planned before. So just you can let this method fail before noon, and then from noon onwards it will run just fine. Between, which is nice, so you can say fail between lunchtime and when lunchtime finishes. So everyone who doesn't go to lunch is screwed. Every end call, so if I say every 2 calls, then it will run fine the first time, not the second time. It will find the third time, not the fourth time. Planned at, so only fail at a specific daytime. So you can say on the weekends it will fail until it's called that many times, or when it's called exactly that many times. And there are some combinations. You can say planned at today and after 12 o'clock. So you can combine them as well. In this case, I think I said that I was going to do after 2 times, which means that the first 2 attempts to sign in will work, but then it will start failing. So let's go ahead and try this. And I keep saying this, I need a faster laptop. There we go. So first time, I'm gonna just enter my PIN code and it will work. I can log off again. And the second time, let's say that I enter a wrong PIN code. Then it's just Windows Hello saying, oh, something went wrong. Might be exactly the same if you have an iris scanner and you're like half away from the screen, it doesn't recognize you. It will say, please try again. So let's try again. Still works. But if I try now to do it the third time, that's not gonna work anymore. And it will crash my application, which is not a good user experience. So what happened? Yeah, it threw an exception, that's what happened. I let it throw an exception. But I can also go in, and my counter has reset now because it will reset every time your app domain loads. It actually logged an error in here. And you can see that, of course, this is the row library that's been affecting your call. But it happened here in the inventory view models login view model in the method login with window hello, which is also containing a typo, apparently. So in this method, we call the login service, and it failed because Windows Hello was misbehaving because of me. But I want to fix this. If something happens with Windows Hello that I can't control, that should not make my application crash, right? So let's fix this. If I go to the login view model, this is the method login with window hello. I can see it just tries to call sign in with Windows Hello Sync, and if it's okay, it will enter the application. If it's not, I entered the wrong PIN code or I canceled, it will show that message, you canceled, and it stops trying. But of course, it's a little bit naive and didn't check on exceptions from occurring, so let's just wrap this in a good old try catch and say, if you have an exception for some reason, then we'll just say Windows Hello, Windows Hello is currently unavailable. So now if I quickly try this again, I'll just cancel out of the dialog twice. Cancel. This is the normal experience. You canceled out of Windows Hello. I can still log in the second time, but if I now try to log in a third time, it will just say Windows Hello is currently unavailable. Something happened, which doesn't crash the application anymore. So I can still sign in using the old way, and I'm still able to enter the application now, which is a far better user experience. So that's just the first trick, external service. You want to know what it would do into your application if it starts misbehaving, and then you can, deal with that result. Another thing you can do is start messing with services being slow. So as you can see, this application shows you a number of customers and orders. But what would happen, let's say that our customer service is using a big CRM system, and we are still running that on a, let's say, a Pentium 100. So it's very, very slow for some reason. And at some point, when it starts doing batch processing, you just notice that it's gonna take a lot more time to get your data. So again, I'm gonna go to the service locator, and this time I'll affect the customer service. Now it's purely coincidence that I'm affecting singletons. I can also affect the scoped and the transient services, but it just happens to be in this application that all of the services that I want to do something with are singletons. So this time, I will affect the method get customers async. There we go. But this method has some overloads. So it has one with a data request of customer and another one to skip and take, so for paging. But I know that in the screen that I want to show, I'm only needing to overload the first one with the data request. But of course, at this stage, I just want it to fail at a certain time. I don't really care about what kind of request that I'm doing. So it's, again, just like with a mocking framework, you can say for this request or I don't care. And the I don't care version of row is with. So if you call this method with any type of data request of customer, and I have to bring in the inventory data namespace. Thank you. So when I'm calling that method now with any request that you're giving to that method, let's slow it down by 30 seconds. Nope, 30, not 300. And again, I'm not going to do this every time. I'm only going to do it every second time. And with this, we can test if our Windows application will behave correctly, because we're supposed to use async await now to make it more responsive. Because if you don't, remember Windows Forms applications, they became white, and then the title bar started saying not responding. We're not really in that time anymore. So let's see if our application can deal with being slow. So I'm going to load the customers for the first time, which was very fast. Only took 0.146 seconds. And if I now go to another screen and I go back to customers, you will see that it will take a lot more time to finish. But you can also see that maybe you can't, but the Fluent design is still responsive and I can still move the screen around. And it's not becoming white, which is a good thing. It's not saying not responding, but it just takes up to 30 seconds and I need to start to continue talking because otherwise you will fall asleep. It's also pre-lunch, so, well, that's actually a good thing. If it was post-lunch, then you would be asleep. Voilà. And now I have my customers and it took 30.1 seconds because it took 0.1 to load and 30 to wait. but it's still responsive. So while this is not the best of results, your application was apparently doing nothing for 30 seconds. It didn't crash. It didn't show that widescreen experience. But you could think of enabling like a circuit breaker pattern in here to say, if I'm doing these calls, for example, with an HTTP client or a SQL server, and they start taking more than the average of 5 to 10 seconds, then stop doing what you're doing, use the cache instead, and retry after a certain amount of time. But that would take me too long to implement in this demo, and I want to show you more stuff. So let's go back, and I'm gonna change this to 10 just in case I hit that one again. Don't want to be stuck for 30 seconds again. I think I showed you in the first demo the activity log, right? So everything you do in this application is being logged. So what would happen if my disk was starting to get full? So let's try and simulate now that event. So I have this log service, and just like before, I'm gonna override a method, in this case write async. And this method again has parameters, so I'm gonna have to add a lot of these now. The first one is a log type, and then I have a few strings like the source, the action, the message, and the description, I think. So I have to do 4 of these. Yep. And simulating that you're out of disk space means throwing an IO exception. So, and I've used that one before with the generic way, but you can also just say, I want to throw a custom IO exception, which is in the system.io namespace with a message, no more disk space. And yeah, this time I was going to do it after 3 calls. So let's run the application again. And just as you, to make sure that you know, when you start the application, that will already do 1 log event. So I took 3 because that's already 1. If you took 1, you would crash immediately. It would not be a very good experience to show. And let's go ahead and change an order. Because I know that if I change an order, it will also log that event. And I will say, okay, this order is now processing, and I've paid it with my credit card. It's safe, no problem, works. And let's say we're gonna add this one to California, also processing, and pay by wire transfer, save, good. And now I say, oh, this first one is now going to ship using, it's gonna ship on that date using federal shipping, and it's gonna crash. That was my 3rd logging event, my 4th logging event. So gonna start the application just real quick to show you the activity log before I show what happened. And you see that I had that my first one. I started the application. I saved my first order. I saved my second one. And this is my current run. So it stopped indeed after 3 logging events. If I go back to orders, you will see that my shipping change did go through, so that's good. Didn't lose that information. But it's actually not that great of an experience because it should deal with the logging not being available and not just crash, you know. It's not the greatest experience. But unfortunately, if I go into the log service into the write async method, and I have to go to this. Yeah, this is the one. It's going to create an app log event with the data that you give it, the source and the type and everything. And then it's going to create a log async, which is using a data source of some sort to write that log into the data source. And actually, this is the method that I should have been affecting. This is the method where I should say, this is going to run out of disk space. But if I look at the interface that has been given to me as a developer, the interface does not expose that method, which is, in this case, it makes me unavailable. Well, not unavailable, but it doesn't help me in mimicking the correct behavior. So I can't fix this at this point. Of course, I can fix it in another way, but the problem here is that the way that this has been made showcases a poor design, because you have a log service with another dependency inside of it. It's doing both logging and writing logging. So in this case, my chaos test showcased bad architecture. Now, up until now, we've done some rather simple things. We're slowing stuff down, we're throwing exceptions. There's one more thing that we can do, which is a little bit more fun. My definition of fun might not be the same as yours, but what I was talking about is we can also change the data that's being returned. Now, of course, we're in a typed language, so I can't change a customer into an order. That would be strange. Unless you have, if you could, for example, if you have a web API and you have the point in your application that receives some XML or JSON, you could affect that JSON or XML, transform it completely, and then see what happens. In this case, unfortunately, I'm more in a typed situation, so I'm not capable of doing that just yet. But I can, of course, change a customer into something else, in another customer. So again, I will affect the iCustomer service. Customer service. And this time I will affect the get customer async, which needs the ID, which is type long. And I have some other effectors which start with returns. So now I can say, when you're calling that method, I want you to return something else instead. And of course, we have the normal versions and the asynchronous ones. So I'm going to use return async and let it return a new customer model, which is in inventory models. And I'll zoom out again. And I'm just going to return something that says first name is chaos. Well, let's say Chuck. And last name is Norris. You don't want to mess with that guy. And let's say that it happens every second call or third. There we go. And this is going to be a little bit interesting because it's affecting a different method. So the first one, get customers async, will give you a list of customers which are not being affected. But then if you're going to get the details of one, something else will happen. So if I go to the list of customers, nothing happens. We have the data that we expect to see. But once I start navigating between them, all of a sudden you get Chuck Norris instead of Adrian Sanders. And it happens every third time. So if I now say 1, 2, and 3, no, double click, 3, I get Chuck Norris. But of course, because everything else is null or not filled in, I'm getting also a spinner. Luckily, it's not crashing because if I move, it's recovered. all of a sudden, but something was off. The software was expecting something that was not there, and it was like, oh, I'm still in a busy state. I don't know why. Please help me. Probably related to the fact that I'm created on the 1st of January of the year 1. I don't know what happened here. But also my customer ID is empty, so I can't edit or delete this anymore. But again, that's just version 1 of playing around with data. There is another way, which is a little bit more difficult to implement. But what if I want to change the data that was coming back from that get customer async? Because up until now, whatever I've been doing, except for the slow it down, is I intercept your call and I do my own stuff. When I do the slow it down, I intercept your call, I let it wait for a time, but I do call your service and return whatever it's supposed to return. But now I can also say, do get customer async, give that to me, I will change it and then give it back to you. Now I'm just replacing. But if I throw this away, and I'll zoom in a little bit, there is a overload of this method, which looks, don't mind this part. It looks a bit big, it's system trading tasks of T, blah, blah, blah. Very difficult. I'm not going to read it. But that overload allows you to get whatever should be returned, transform it, and send it back. So unfortunately, I have to do it this way because C# doesn't allow you to play around with link expressions too much. It's at some point, there are limitations in the language. So I have to do some custom code here. Maybe I find a way to make it a little bit more coder friendly, but this is what I got for now. So I have to create my own func that gets a asynchronous customer model and returns a task. So it remains async await. And let's call this one transformer. And so we can say async equals async task. And we're gonna await a task, customer equals await task dot configure await false, because if you've seen Philip Ekberg's other session, you should use configure await false here. And if customer is null, because that can still happen, let's just return null, turn null, there we go. If not, we're gonna change this one again into Chuck Norris. And let's do something extra and say the picture source is null and return customer. And now I can use that transformer method in this returns async one. So I'm getting my task and say transformer with that task. But I also need to say, because it can't now determine which overload are you referring to, so I have to say I'm referring to the one that transforms a task of customer model into another task of customer model. Whenever I finish this, I will have plenty of documentation guiding you through the process. Maybe I have a better way to do this, but for now it works. So let's see this in action. Compile and go, please. Also, it amazes me every time that I can do this demo live without any build errors. Applause to myself. Thank you. Customers. So now every third time I call get customer sync, you will see that I'm now only replacing the first name, the last name, and the picture. So you can see that Adrian Sanders still has his picture in the list, but now he's become Chuck Norris without a picture. And again, I can do the same if I do 1, 2, and then double click. So I can now edit this customer with this ID, and everything else is still the same, but I just changed some of the data, which can help me now to, if I know the code behind this, I can really start messing with your application and replacing, for example, the ID with something completely different, and then see if you check everything. Or if you have, if you use a timestamp field in SQL Server for conflicts, then I can change that timestamp and see if your application can deal with it. So then you can see if you have a good concurrency detection in place. Now, go back to the slides. If I take the right one, this is the point where I typically start my presentation from the beginning again. So you can find all of the source over there on my repo, and this is just a first step in chaos engineering. So with this, you can start messing about in your .NET code base to showcase what chaos engineering is, because it's very controllable at this point. Also because it's not every time possible to just add agents in Docker containers everywhere, because not all developers have administrator rights, I've been told. So yeah, I would suggest have a look at the code base. There are some issues logged. I'm, for example, working on supporting AutoFac, because that's a very high request. I'm also still working on actual implementation of, because now I'm only allowing you to override methods that return something, but I'm currently working on void methods, property getters and setters as well. Property setters are a pain to implement, by the way. You would not believe. So yeah, still a lot of work to be done, so feel free to check it out. You can also help out if you want to, or just spam me with requests. One of the requests that I got was really interesting was BDD support, so that you can really have features saying, when I call this method, slow it down by 30 seconds and then return the data. So that would be very cool, just to have testers implementing chaos in English like that. So who knows, might come in the future as well. Still in beta, gonna be in beta, well, alpha for a while. I don't know. People tend to use alpha beta before going to release. I just call it alpha right now. We'll see. So yeah, thank you for being here, and I'll take any questions if you have them. Yeah.
What are your thoughts on potentially integrating it into a continuous integration pipeline?
So the question was my thoughts on integrating this in a continuous integration pipeline. Yeah, could be part of your testing process. So where you have some test runs that say, does my circuit breaker pattern run correctly if I start slowing stuff down or having exceptions? And yeah, that could be part of your environment as well. So you could trigger this with a flag in your configuration and then enable it. I also know that there's an open source tool, I forgot the name, sorry about that, but there's an open source package that plans chaos experiments, which also enables you to plug in your planning with the tools that you deploy. So I could also listen here to that service so that you can plan your experiments using that tool and then have it report to that service again. So there's plenty of opportunities to enable this on both just runtime, but also in test environments, automated tests, and yeah. Someone else with a question? You can still, oh yeah, right in the back.
What events normally would you add chaos to? So you made an example about destroying method space.
Mm-hmm.
What are other examples that you would normally add chaos to?
So other examples of when you would add chaos. Basically, every external service you depend on. Because especially if you can't control them, So if you have a dependency, let's say on a service that sends emails for you, and you're not building that one yourself, you should test what happens if that one goes down. Because if sending email is a critical part of your flow, you should make sure that that email gets sent out. If not now, then when the service comes back online. So that's something that you should really test for. So basically, all external things that you can't control in your application, which also means that if you are in a microservice world, you have to do that for every microservice that you're calling, because you don't own them. Or perhaps you do, but you don't own the system that runs them. So you should actually have a look at almost everything that you do with chaos engineering, to be honest. Yeah?
Do you intend for your tool to be used in the way that you kind of demonstrated it today, or do you expect people to more have it as part of like an integration test or something like that?
Depends. So of course, this is a demo, so I can only do it. I can only show what I can show right now, also because it's not finished yet. But I would see it becoming part of a testing process in your application. But I'm not that familiar with everything, because I know that I've seen cupboards of phones springing to life and then running some tests. So that could be the same, so that you deploy Xamarin application with some chaos on a device and then have it run a test suite. So that could be with BDD tests, then, that you just run those tests and see what would happen if my applications can't reach the service for that call and the second time, that they should fall back to their caching, or just retry it after a certain time and then it should work again. So I think it would more become like an automated testing, just like you would do with integration and other tests. You can still run it locally on your device just for some checks, because I know a lot of developers do their own tests as well. So, but I think it will be more suited for running automated tests. All right. Should you have more questions, I will be around today and tomorrow as well. I might go out and see some of Sydney because it's my first time here. But I will definitely be around if you have more questions, and happy to talk. Thank you.